We've gotten a decent understanding of the theory of containers, but before we start our labs, we should look at a few things to help us better understand how to operate a container. Let's first start by revisiting those image registries. We discussed image registries before, but let's take a little bit closer look. We know that an image registry is a location that stores our container images. What we didn't discuss is the image cache. The image cache is a collection of container images that have been downloaded on your container host. Images stored on the container host don't need to wait for the image to download from that image registry over possibly a slower WAN connection. It just takes more time to start up those containers. If an image is already stored in the local image cache, it can be quickly started by the container runtime. On the other hand, if you attempt to start an image that does not have a cached copy, the container runtime will download the image before starting it up. The next time you go to start this image, you can start it again from the image cache as opposed to having to download it again. The last point I want to make is about the image registries is that there are lots of them. The default image registry configured by Docker is Docker Hub. But you can use any other image registry that you'd like to. There are public registries like GCR, which is Google's container registry, or Amazon's Elastic Container Registry, for example. It's often the case that companies deploy their own image registry behind their corporate firewall for security reasons. Great. Hopefully we're getting the idea about these container registries. So how do we use an image from one of these registries? Well, when running containers, these container images are identified using the format shown here on the screen. First, we identify the repository that stores the container. Next, we specify the image we're looking for. And lastly, we specify the tag. Tags are often used for versioning of a container such as v1, v2, but can really be named anything. Let's take a look at a few examples of container image names. In the first example, we're identifying an image stored in the Docker repository named Ubuntu and has a tag of trusty. This tells us where to find that image, Docker Hub, the image name of the container, which is Ubuntu, and in this case, the version, which is trusty tar, and it's identified by a tag of trusty. We can also see that there's an additional image in the same registry, in the same repository. They're both named Ubuntu, but this one has a different tag, and this one's named Bionic, presumably for Bionic Beaver. In the next example, this one looks quite a bit like our first example, except it's missing the repository. Since Docker Hub is the default repository for Docker installation, if you request just the image Ubuntu with a tag of trusty, the Docker client will know to go out to the Docker Hub and pull that image down. So you don't have to specify the repository. If you don't specify one, we're going to assume it's Docker Hub. Same case in this next one, although in the next example, we have a tag of latest. Latest is a special tag used for the most recent version of a container. Now there's opinions about whether or not you should ever use the latest tag, but that's for another discussion. Just know that if you use latest, it means it's supposed to be the latest version of the container. In this next version, we don't have a tag at all. And if you don't specify a tag, it assumes latest. So here, we only specified an image of Ubuntu. We didn't specify a repository, we didn't specify a tag, but this is going to mean it comes from the Docker repository, and it's using the latest tag. It's really the same as the previous example. And finally, in our last example, we see we've got a container images stored in gcr.io/kuar-demo. And this is the Google container registry with the kuar demo repository. And this is for the Kubernetes up and running demo. The image name is QRD AMD64, and it's got a tag of green. So the point of this is you can get these images from different repositories with different versions, and this is how you're going to specify these in the command line. Now I won't go into too much detail here, but I think it's important to understand that these container images are built in layers, each layer building on top of the layer below it. If we looked at a Docker file, which is used to build a container image, you would see a list of commands in the file. Each of the commands is its own layer. Each container image starts with a base layer. In this case, we're starting with the Nginx Alpine container image, which we can assume has the Nginx daemon installed in this base layer. For us to really use the Nginx container, we need to copy our own custom HTML into the container to use, right? So when we build the container, we copy some files, like in this case we use index.html, over to a location in the container. This command builds a new layer in the container image on top of that base layer. Then, of course, we want to expose the container on port 80 so that we can access it via web browser. This also creates a layer, even though the expose command is really an empty layer. And then lastly, the order in which you issue these commands matters. If we were to add a new copy command to add additional HTML files, for example, the layers below this new layer don't have to be rebuilt. They are the exact same layers. However, any layers that come after this command may need to be rebuilt because their base layers have changed. This is important when you're building images so that you don't have to rebuild the entire container, just the layers that need the modifying. Let's switch gears over to networking real quick before we start looking at some things in the command line. Networking is a confusing topic for many of us, but important for us to know a few of the basics for container images. The first thing you should know is that all containers get their own network namespace. Each namespace is isolated, and we've talked about namespaces previously. Container networking can be configured in different ways, of course, but the default installation for Docker is to use bridge networking. This method creates a virtual switch inside of the container host so that those containers can talk to each other. Now, by using the expose command, you can expose a port on the container inside of that container host. You can see that the two containers that are deployed here are exposing two different ports. One of them is the unsecured port 80, and another one is a secured port 443. Now, to make those ports usable by someone, you can map the container port to a host's port at runtime. In this example, we can map port 8080 on the container host to port 80 on the running container. We can open a web browser and navigate to http://localhost:8080 to view the running container, presumably. In part 2 of this lesson, we'll actually start interacting with containers from the command line.